Camps on everyone. Let's start off. The last thing we did, just particles chasing each other. Great. Next thing, rainman problems or rain umbrella problems. The idea is pretty simple. So when a person walks in a rain, so if you're just standing there and let's say rain is falling, and if you start moving front or back or right or left, right, what happens? Because of relative motion, you think the rain is falling at a different angle. You must have noticed that. Now it's a rainy season, right? Try to observe this. Let's say you're going to your classes in a car or bus or train or something. When the train stops or when the bus stops, just look at the rain. And when the bus starts moving, look at the rain. You'll observe the rain is literally changing angle. If you've ever noticed it. So try to observe this in the recent time. So when a person walks in a rain, due to relative motion, he observes rain is falling at a different angle. Right, with respect to the ground. There. So simply what you're trying to say is whenever the rain is falling, right, who is the observer? Observer is the man. So in relative motion, remember what is step one? Choose an observer and subtract the velocity. So in rainman problems, we don't have that headache. We always know we have to subtract the velocity of the man. So the idea is pretty simple. Let me show you with an example. So let's say we have a person here who is going with speed u. And let's say the rain is falling vertically. With respect to the ground. So what is step one? Stop the man. So let's study with respect to the man. And how do we do that? So you take the man ka velocity, u forward. The rain is falling with v. So take a vector u backward and add it u backward to everyone. Isn't that what we do for relative velocity? When you do this, the man will come to rest. The man will think, okay, I'm at rest now. And you will think the rain is falling with u this way and a v this way, right? And the resultant will look like this. So the man will think the rain is falling at an angle. So technically it is falling straight because you are moving. You get an illusion that the rain is falling this way. This is the direction of the rain as seen by the man. If I take this angle to be some alpha, tan alpha will be u by v, where alpha is the angle with respect to the vertical. And the question will be like this: how should I keep the umbrella? So you should keep an umbrella in this direction in order to avoid the rain. So this is also alpha. So they'll ask you like this: how should the man catch the umbrella in order to avoid the rain? Are you getting the story here? So here, if you ask this man, with what speed is the rain falling, he will say, this person will say, man feels rain is falling with speed, he won't think speed is v anymore. He will think speed is root over v square plus u square at an angle alpha with the vertical. I hope you're getting it. That is what he will think. Whereas in reality, the rain is still falling vertically. Is that clear? Is the idea clear, everyone? That's it. That is the whole concept of rainman problem. Stop the man, take his velocity, subtract it to the rain. Man will come to rest. Now see what is the rain doing, and you'll get the new angle and everything. Let's see a few questions. That's the best way to get it. But technically, this is the whole concept of rainman problems. We have done more dangerous ones, so this thing looks okayish. Any doubts on this page? Clear? Let's see some problems. Let's say we have a man. This guy is going with 10 meters per second. So here the rain is falling at an angle 30 degrees. So this is the velocity of the rain with respect to the ground. Is also 10 meters per second. So the question is, find the angle made by the rain as seen by the man. With respect to vertical. As seen by the man. Let's get this. So man is going straight with 10 and the rain is falling at an angle of 30 degrees with the vertical 10 meters per second. Now, if you ask this person, boss, how is the rain falling? What will he say? Right, Samir. Anyone else? We have one answer. This was easy. Right, Ekansh? Anyone else? Right, Arya. See, step one, first resolve the velocities. So our man is going with 10 meters per second. The rain, if you take the components, the vertical component of rain is 10 cos 30, 10 sin 30. So stop the man. How do you do that? Take 10 backward, add it like this, add 10 here. So this man will think, okay, I came to rest. And he will think the rain is falling with 15 meters per second now, because 10 sin 30 is this. And this is 10 cos 30 is 5 root 3. So he will think the rain is falling like this. This angle is alpha. Tan alpha, opposite side 15 by adjacent side 5 root 3. This will be root 3. 60 degrees. Easy? So the rain which was actually falling at 30, but this person thinks it is falling at 60. Is the idea clear, everyone? That's it. That's a simple way of putting it. So we have a very fancy way of writing this. You can also use all technical terms like this. Velocity of man with respect to, velocity of the rain as seen by the man is nothing but velocity of the rain with respect to the ground minus velocity of the man with respect to the ground. If you actually think about it, isn't this what I'm doing? I'm subtracting the man ka velocity from the rain, isn't it? That only I'm showing you on a picture. But this is a mathematical way of writing it. Sometimes you will see terms like this, so don't get scared. You're doing that only. Look at this. You are subtracting man ka velocity from the rain. That then you'll get a relative velocity. So you can also use the terms here. So VRG will be nothing but VRM. VMG. Yeah, you can write this, but I don't think we'll use this anytime. I always prefer to put a picture. It gives you better clarity what is happening. But got this thing? Let's see one more. Let's say 45 degrees. The man is walking like this with 10 root 2 meters per second. So the man is walking at an incline. The rain is falling with speed v here at an angle of 30 degrees. So this is the velocity of the rain with respect to the ground. That is the actual velocity of the rain, which I don't know, which is not given. So the question is this. Find velocity of the rain if the man sees the rain falling vertically. So technically the rain is falling at an angle, but he thinks it is falling vertically. And find the speed of the rain as seen by the man. And in the same scenario, when he thinks it is falling vertically, find the speed of the rain as seen by the man. So there. So we have a man going on an incline at 45 degrees. The rain is falling at 30 degrees. That much information we have. But I don't know the speed of the rain. But this guy thinks the rain is falling vertically. So what is the speed of the rain? And with what speed is the rain falling with respect to him? Right, Arya. Try. Everyone try. I'll give you a minute or two, then I'll show you. Yeah, most of you got it right, Ishwan. Everyone should try. Take a minute or two. If you got it, great. Like I said, easy stuff. You always just stop the man and do it. Compared to what we did last time, these are like little okay. Let's see. Yeah, I think the speed looks messed up. 20. Got such a good number. Most people got 20 by root 3. Yeah, answers look bad. Let's see. First thing, resolve the velocities of the man and the rain. So if you look at the rain curve components, this will be V rain cos 30. This is V rain sin 30. This is 30 degrees. If you look at the man here, this horizontal component will be 10 root 2 cos 45, 10 root 2 sin 45, which is actually 10. So you want to stop the man. So what you do? Subtract it. So subtract 10 downward, subtract 10 leftward. I need to do the same thing for the rain. So add 10 to the left and add 10 to the down. Isn't it? Whatever you do to the man, you do the same thing for everyone. You add 10 to the left and add 10 to the down. Now the man will think, okay, I came to rest. Again, in rainman problems, the observer is always the man. Just stop him. And he will think, now the rain, he thinks the rain is falling vertically. So look at this component here. So this will be 10 plus V rain sine 30. This is 10 and this is VR cos 30. Now you tell me, If the rain falls vertically, means what? Horizontal component is 0. Since he sees the rain falling vertically, VR cos 30 minus 10 must be 0. Therefore, VR will be 20 by root 3. This is the actual speed of the rain in the ground frame. But this person will think the rain is falling with 10 plus VR sine 30. So he sees rain falling with 10 plus VR sine 30 vertically. That is the speed he thinks. And how much is that? So that is 10 plus sine 30, so 10 by root 3. So he thinks rain is falling with this speed. If he is going down, that it is possible. You have to run faster than the rain in the downward direction. Is this making sense? Any doubts on this? Here you got something. Param, clear with this? Satyasha? Trishi? Utsa? Siddhesh? Advait? Advait, I can't see you. Adjust your camera. Advait? Clear. Let's see. The next one is a good one. This is like I said, there's really not much you can ask in this, but if at all they have to ask you something in advanced level, maybe this would be a little decent one. We have a path like this. This is 30 degrees. This is 60 degrees. This is A. This is B. This is C, and this is D. So BC is horizontal. AB is 30 degrees and CD is 60 degrees. So we have a man here who is walking with a constant speed of 10 meters per second. So he walks with 10 meters per second on AB. He walks with 10 meters per second on BC. He's walking again. So he will just maintain his speed. The man is walking with 10 meters per second every time. Man walks with constant speed. Ten meters per second on ABCD. Now, this person observes when he is walking on AB, he sees the rain falling vertically. Meaning when he is going on AB, he thinks rain is falling vertically. On CD, he sees rain parallel to CD. That means when he's coming down from C to D, he thinks rain is falling like this, parallel to CD. So the question is, at what angle does he see the rain when he is on BC? Is the whole scenario clear? No, we will not do that thing. One method is sufficient. That is a waste of time. That's what I keep saying. Just learn one method and just use it properly. Don't worry about multiple things.
So we have to give the angle with respect to horizontal or vertical.
Yeah, you can give it both. Near Shreyansh. Nee, Param. How are you guys getting 45? It's not 45, right? 60. At what angle does he see the rain falling when he is on BC? T. No, I don't think you'll not get a good angle, right? Why are you guys getting such good angles? 30s and 60s and 45s, interesting. First of all, how is the rain actually falling? Did I say the rain is falling vertically? When you are walking on AB, he thinks rain is falling vertically. I never said rain is actually falling vertically. When did I say rain is falling vertically? On AB, he thinks rain is falling vertically. The rain was never falling vertically. I think you guys have just taken vertically and started doing the question. So if I ask you how is the rain actually going, with what speed and what angle, we don't know that. That is not given. The rain is not falling vertically. Did anyone first? Let's start with that. How is the rain actually falling? Let's start from there. Tan inverse 1/3. Okay, that's not a good angle, but still that's not the answer. Let's start from CD. The whole question starts from CD. This is 60 degrees, this is C, and this is D. Look at this. So when this person is walking along CD, so this is the velocity of the man with respect to the ground. And you're telling me he thinks the rain is hitting him parallelly, so he thinks the rain is also falling. This is the velocity of the rain as seen by the man. RM mini rain as seen by the man. Now, if you try to write this vectorially, velocity of the rain as seen by the man is nothing but velocity of the rain in the ground frame minus velocity of the man in the ground frame. Now, if you notice something here, so this velocity of the rain in the ground frame is Vrm plus Vmg. Great. These two vectors are parallel to CD. Now you tell me, if you add two vectors parallel to each other, what will be the resultant vector? That also has to be parallel to CD. Ah, Samyak, you got it. Isn't that making sense? If you add two parallel vectors, the resultant is also parallel. Right? Vectors are parallel to CD. Therefore, the resultant also must be parallel to CD. there. So rain is actually falling at an angle of 60 degrees with the horizontal. Therefore, velocity of the rain in the ground frame is also parallel to CD. So the rain is actually falling like this. The velocity of the rain in the ground frame is falling at an angle of 60 degrees. That's your first information. I still don't know the speed of the rain. That's not the answer. Is this first part clear, everyone? The rain is not falling vertically. I said on AB, you think it is falling vertically. The rain is actually falling at an angle of 60 degrees with the horizontal. This is not the question that I asked you. Then what? Now go back to AB. So on AB, the man is going with 30 degrees. If you resolve the velocities, man ka velocity will be 10 cos 30, 10 sin 30. This becomes the previous problem. And we got velocity of rain, whose magnitude I don't know, but I know this is going at 60 degrees. So this component will be VR cos 60 and VR sin 60. Stop the man. 10 cos 30, 10 sin 30, 10 cos 30 and 10 sin 30. Now the man will think, okay, I came to rest. And he will think the rain is going here with VR cos 60. This way it is 10 cos 30. And vertically it is 10 sin 30 plus VR sin 60. And he sees the rain falling vertically. Therefore, VR cos 30 minus VR cos 60. 10 cos 30 is 0. So VR will be 10 root 3 meters per second. This is the actual speed of the rain in the ground frame. Any doubts on this? So the rain is actually falling with 10 root 3 meters per second at an angle of 60 degrees in the ground frame. So first you need to figure out how the rain is actually falling. Any doubts on this part? Then you want to find out BC. So BC is a flat surface. The man is going with 10 meters per second. The rain is falling with 20 root 3 meters per second at an angle of 60 degrees. So the components will be 20 root 3 cos 60, 20 root 3 sin 60. Stop the man. So what should I do? Add 10 backward. Add 10 backward. So man will think, I have come to rest. There I am keeping it very simple with the pictures there. So this resultant will be how much? 20 root 3 cos 60 will be 10 root 3 minus 10. And the vertical is 20 root 3 sin 60, which is root 3 by 2, 30 meters per second. Is that clear, everyone? How much did I get? 20 root 3 or 10 root? Sorry, that is 10 root 3. This will be 10 minus 5 root 3. There. So this person thinks the rain is falling at this angle. I'll find with vertical. So we will get tan alpha. This will not be. This will be 15. So you're done. So tan alpha will be opposite side 10 minus 5 root 3 by 15. 2 minus root 3 by 3. That's your angle. How are you guys getting 30s and 60s? Yeah, right. Again, listen to the whole thing we did. The whole problem started from CD. And CD may, it was mentioned when you're going on CD, the man is walking along CD, rain is also along CD. He thinks rain is along CD. That is only possible in one way. The rain was actually falling along CD, isn't it? Because the velocity of the rain as seen by the man is nothing but rain in the ground frame and man in the ground frame. If you subtract two parallel vectors, the third vector is also parallel. That means all the three vectors are parallel. So the rain was actually falling parallel to CD. And when you're in AB, you thought it is falling vertically. That means the horizontal component is 0. That gave you the magnitude of the rain. Now when you're on AB, I know the rain is falling at 10 root 3 at an angle of 60 degrees. Subtract the Manka velocities, and this is what you see. Is this clear, everyone? So the main thing in the question is this, that the rain is parallel to CD. What did you guys do? You guys thought the rain was falling vertically, yeah? How are you guys getting 30s and 60s, such good angles? This thing looks so messed up. Is this clear, everyone? There, Rain Man, that's it. There is nothing more than this in Rain Man. You stop the man and then done. You can see what is happening to the rain. Man can walk straight, man can go at angles, rain can fall at angles, rain can fall straight. These are all the cases. All clear with this? So keep it simple, just draw a picture, you will see things more clearly. There's also a way to do the vector form. I don't like that. So, but yeah, we can see later on. Again, if there are 3 or 4 methods, I'm telling you again, you're not doing any research. Stick to one method which you like, which you're comfortable, which you can do in the exam. Just learn that and done. Don't run behind running 3, 4 methods for the same question. It might feel good, but in the exam, you will go and don't know what you will do. You'll see the question, you will think which method should I use. Instead of chup chap solving the question, you will waste time thinking which method, which method to use for a minute. So don't get into all the trap. Stick to one thing and do it properly. Yeah, but if you're comfortable with something else, do that. Clear? That's the Rain Man thing. The next thing is riverboat problems. Like the main problems you have done in the last class, the particles chasing, particles spiraling, and all that stuff. These are standard models. So riverboat, riverman, there are different names for this. Aeroplane, wind. So in place of a man, we keep an aeroplane. In place of water, we keep a wind. So we have primarily 4 primary cases on this. So let's see them. So first thing, when you have a river, so when you say u is the velocity of the river, what is the meaning of this? The meaning of this statement is if you take an object and if you drop in the water, it will go with you. That's what a river does. A river will simply give you an additional velocity u in the direction of the river. So if you take a paper piece and put it on the river, it will go with you. If I take you and throw in the water, and if you don't know how to swim, you will go with you. So anything that is thrown into the river will go with you in the direction of the river. So if an object is dropped into the river, it gains speed u along the river. Remember, this is additional. If you don't do anything, you'll go with the river. Then we will say we have a man here. So velocity of the man in still water. Matlab, if there is water is not flowing, let's say it's a swimming pool or something, he can swim with V. So if the water was not flowing, it is just a plain pool, then the man will go with speed V. Clear with this? This is the main data there. So what do you mean by this? Let me show you some examples. Let's say the river ka speed is 10 meters per second. So you take a man and just throw him in the river. Let's say he's not swimming. What will happen? The man also will go with 10 meters per second. Let's say the river is going with 10√3 meters per second. Now in this river, you dropped a man. This person is trying to swim straight with, let's say, 10 meters per second. Now what happens? Man swims with 10 meters per second straight. So if you look at the man, now the man will have two velocities. One, because of his own velocity, he is trying to go 10 meters per second. This is your own effort. And the river is dragging you horizontally with 10√3. So this man will not go straight. So this man will actually start drifting at an angle. If you take this angle to be theta, you will get tan theta. Opposite side, 10√3 by 10, you get theta is 60 degrees. That means this person, so even though you're trying to swim straight, because of the river, you actually drift like this at an angle of 60 degrees. Is that making sense, everyone? This is what a river does. If you try to swim straight, the river will drag you horizontally with 10√3. So whatever effort you have, the river will give an additional velocity. So man drifts at an angle. Even though you're trying to go straight, you drift at an angle. Is that clear, everyone? All clear? What does the river do? Whatever is your velocity, river will give you additional u horizontally. That's it. That's what a river does. Any doubts on this logic here? Great. Case one. Man swims along and opposite to the river flow. So we got a river here and it is going with u. So this man is trying to swim with v. This man is trying to swim with v. So if there's a person on the ground observer, you know what he will think? He will think the velocity on the man as seen by the person on the ground is v plus u. Is that making sense? The man can swim with speed v in still water. This v is the velocity of the man in still water. If the water was not moving, I would have gone with v. But if the water itself is going with u, so I'll gain an additional speed v plus u. This guy, the velocity of the man in the ground frame, this will be v minus u minus I cap. It is going backward. If the river is stronger, you will get u minus v. This is easy. You go with the river, v plus u. Go opposite to the river, v minus u. Done. This is case one. This I'm sure you did in school also. Case two. Any doubts on this page, please ask me. Tanishka, clear with us? Case two. Minimum distance. So you want to cross the river in minimum distance. That is, he goes perpendicular to the river flow. His actual path is along perpendicular to the river flow. Now listen to this thing. One thing is clear. If you try to swim straight, you're not going to go straight. That we already showed with an example. So let's say this is point A and this is point B. You want to go from A to B. Now you tell me, if you think if I swim straight, will I go straight? The river will push me this way, so I'll go somewhere here, isn't it? So I'll go at an angle. So if I want to go straight, this is what I should do. I should try to swim at an angle V, at an angle theta. I'll try to swim at that way. And the river is anyway going with you. Let the width of the river be d. And let's take v is greater than you. You can swim faster than the river. So let man swim at an angle theta. So what we do, take the man ka velocity, resolve them into components. So the man ka velocity is v cos theta straight. This velocity is v sin theta. And your river is pushing with you horizontally this way. This is the speed of the river. See, that's what a river does. It will always push you horizontally with you. Everything else is your own effort. Now, since you want to go straight, tell me what should happen. If you want to go straight, then the horizontal component must be 0. Since he goes along AB, the v sin theta minus u must be 0. Therefore, we get sin theta is equal to u by v. There, this is your first result, everyone. So if you want to go straight in a minimum distance, you should swim at this angle. What about the time taken then? And how long will it take to cross? Again, let me show you the picture how it looks. If this is the river, this is how it looks. This person is looking like this. Can you see? He's at an angle. He's looking like this, but he's going straight. You're getting it? He's looking, he's trying to look in this direction. He's going this way. He's trying to swim at an angle, but he's going straight. But he goes along the vertical line. So you're looking somewhere else, but you're walking somewhere else. Can you imagine that? Meaning, it's like if you're looking in my screen and look at this thing, it is like I'm looking like this, but I'm walking straight. That is how it feels for this person in the river. Is that making sense, everyone? So you're swimming like this, your hands are going like this, but you're going straight. Is the picture is clear, everyone? Able to visualize that? What about the time taken? The time taken is nothing but AB. So you are going with what speed along AB? V cos theta. But what is cos theta? Sin theta is u by v. So AB is d by v. Cos theta is root over 1 minus sin square theta. 1 minus u square by v square. We get time is equal to d by root over v square minus u square. This is your next result here. So if you want to go in a minimum distance, this will be the time taken to cross the river in minimum distance. Remember, the time is not minimum. Distance is minimum, but time will be something else. These are the two results for the minimum distance. So with what, at what angle should you swim? Sin theta u by v. In how much time will you cross the river? D by root over v square minus u square. Because you're not using your full velocity to cross the river. You're using only a part of the velocity to cross the river, which is v cos theta. And you're using v sin theta to cancel the river curve flow. Is this clear, everyone? Case 2. Any doubts on this? Shaunak, clear with this? Siddesh? Srihari? Ovia, clear? Ishman? Ishman? Clear with this? Devanshi? Arya? Great. Let's see a question on this then. So we got a river here. Which is flowing with you. So you decided to swim in a square. So inside the river, right, someone marked a track like this, which is a square track. ABCD is a square of side L. So we have a person here. So velocity of this man in still water, matlab, if you just leave him in a swimming pool, he can go with V, where V is greater than U. Getting it? So the man swims along ABCD. Understand, the man when he's swimming, he'll swim along AB, then he'll go along BC, then he'll go along CD, then he'll go along DA. He will follow that exact square ka path every time. Man moves along ABCD. Find the time taken for one trip. He's not swimming along AB, huh? He's actually going along AB. Understand the difference between the two words. The way I swim need not be the way I go. Look at this question. How am I trying to swim? I'm trying to swim this way. How am I going? I'm actually going this way, vertically. Are you getting the difference? So how I swim and how I go are two different things. In a swimming pool, the way I swim is also the way I go. But in a river, because the river is pushing you, it will change. That's it. If you understood the difference between those two words, I think you got the hang of it. Let's try. Case 1 and case 2, I combined both of them.
Sir,
Yeah, Param. Hello. Ha, Param.
sir, in this case, if we go into the frame of the man, he's always swimming with a speed u, irrespective of the path, right? Like
With respect to whose frame?
his own frame.
Then it will be at rest, right? Man will think he's always at rest. If there's an insect sitting on man ka head, what will it think about the man? No. So think of like that. Let's say there's an insect sitting on my head, it will think I'm always at rest. It will think the world is moving. The way we think, right? We think the earth is at rest and all the planets are revolving around us. Ishman got something. Yeah, that may be looking right. Let's see. It's a little difficult to type. Ha, Shreyansh. I think Ishman, it's the same thing. I think you got it, Ishman. You also got it, Shreyansh. Try, others try. I'll give a minute more. This is case 1 and case 2. When you go from A to B, it is case 2. B to C, case 1. C to D, case 2. D to A, case 1. Right, Arya. Right, okay, you got it. Let's see. Right, Samyak. Right, Utsa. Yeah. Listen, let's divide the whole thing into 4 pieces. Now, understand here, you want to go along AB. It doesn't mean I should swim along AB. So this person is trying to swim like this at an angle V at an angle theta. Just now we saw this thing. That means he's actually going with V cos theta. So you have to use some of your velocity to cancel the reverse speed. This is V sine theta. And the river is pushing with you. This is your case 2 actually. Since you're going along AB, V sine theta is equal to U and sine theta is equal to U by V. And the time taken to go from A to B is nothing but L by V cos theta. We just now derived the same thing, root over V square minus U square. When you're going from B to C, you're going with the river, so your speed is V plus U. So time taken to go from B to C will be simply L by V plus U. Similarly, when you want to go like this way from D to A, your speed is V minus U. So time taken from D to A is L by V minus U. When you're coming from C to D, same story. You need to swim at an angle V at a theta. So whenever you want to go along the perpendicular line, the time taken will be this much only. L by root over V square minus U square. This is CD. You're done. So the total time will be L by root over V square minus U square 2 times plus L by V plus U plus L by V minus U. You can further simplify this. That is fine. You'll got the answer. Clear with this? Yeah. You can do the denominator, get V square minus U square, all that stuff. You'll get it. So how is this guy actually going? See, if I had to show you how he's actually swimming, this is what he's doing. The river is flowing with you. So when he's going from A to B, if you actually look at the way he's swimming now, he's looking like this. This person is looking at this side and he's swimming like straight. When you're in B to C, you're looking straight. When you're in C to D, you're looking like this. Are you getting how is he swimming? He's looking somewhere else and he's going somewhere else on AB and CD. He's going like this on DA. I hope this is getting. I know that looks like a fish or something, but I hope you got it. So this is what I was saying. You're looking somewhere else, but you're going somewhere else. That is because of the river cut drift. Any doubts on this? So each section, AB and CD are case 2 and the other 2 sections are case 1. Case 3, shortest time. If you just want to cross the river in the shortest time, it doesn't matter where you are reaching. You just want to cross the river. It need not be the opposite point. Then the best thing to do is, you can just say this theoretically, just don't waste your energy fighting the river. Let the river do what it wants. You just swim straight. But anyways, let's prove that also. Let the man go at an angle V at a theta. So this vertical component is V cos theta. This component is V sine theta. So the time taken to cross the river will be distance d, and the velocity responsible to cross the river is V cos theta. Since you want minimum time, the V cos theta must be a maximum. So this V cos theta is responsible for crossing the river. The V sine theta is useless. It doesn't let you cross the river. So for minimum time, denominator has to be maximum. Cos theta is 1. So yeah, theta is 0 degrees. So therefore we get the minimum time is simply d by v. You just ignore the river and just swim straight. So, how will this person look like? He just swims straight. So you're looking forward, but you're going like this. You're looking straight, but you're going at an angle. You will drift. This is A, this is B. So you won't reach point B, you'll reach point C. This distance B to C is called drift. Drift is calculated by horizontal distance traveled along the river. Which is given by horizontal velocity into time. So if you just try to swim straight, you won't reach the opposite point, you'll reach somewhere else, but you'll reach in the shortest time. So here your horizontal velocity is the river ka speed u and time will be d by v. There, this is your drift in this case. Is this clear, everyone? So be careful. The minimum distance need not be the minimum time. Minimum time is not the minimum distance. If you just want to cross the river, just swim straight. Ignore the river. But the catch is you won't reach the opposite point, you'll reach point C. Any doubts on this? So here you're looking straight, but you're going somewhere else. It's like you're looking straight, but you're walking at an angle. You're drifting to the sides. Any doubts on this? This is case 3, easy one. Case 4, this is the last case. Minimum drift. Now, this case occurs when the man ka speed is less than the river. Let's say velocity of the man in still water is less than velocity of the river. Now, in this scenario, since your speed is less than the river, you can never cancel the river ka velocity. You cannot reach the opposite side. The man can never reach the exact opposite side. Because your speed is less than the river. So the question is, fair enough, you can't reach the opposite side, then what is the closest you can get there? Let's say this is D, this is A, this is B. You can't reach B here because your speed is not strong enough to cancel the river. Let this be V, let this be theta. So if you look at the man ka velocity, this is how the components will be. You will actually drift along some line like this to see. So look at the man ka velocity. So man is going straight with V cos theta. He is trying to fight the river with V sin theta. But this river is dragging you with U. So if you look at the man ka velocity, it will be V cos theta straight ahead. And horizontally, it will be U minus V sin theta. This is the speed of the man. So the time taken to cross the river is V cos theta, that is responsible for crossing the river. BC, which is your drift, is nothing but the horizontal velocity. In this case, it is U minus V sin theta into the time D by V cos theta. This is UD by V sec theta minus D tan theta. So this is the drift. Now we need to do maximum minima. So there are two ways to do this. One is pure brute force maximum minima. There's another way to do with vectors. I'll show you that also. But first, let's try to understand this. So we need to find the minimum drift now. We need to do maximum minima for this function. Let the man go at an angle theta. Unfortunately here, man ka speed is less than the river. So the V sin theta can never cancel U. So no matter how much hard he tries, you will always drift. You will reach some point C. So if you look at the man ka velocity, there are two components, v cos theta straight and v sin theta horizontally. So the horizontal velocity will be u minus v sin theta and v cos theta straight ahead. The v cos theta is responsible for crossing the river, so time will be d by v cos theta. And the horizontal drift is caused by the horizontal velocity into time. Is this clear so far? Any doubts on this page? All we are doing is simply speed into time. So we get the drift BC u dB y sec theta minus d tan theta. Since you want to minimize this function, maximum minimum, dy d theta BC. u d by v sec theta का differential is sec theta tan theta. Tan का differential is square theta equal to 0. D goes off, you will end up with u by v tan theta minus sec theta is equal to 0. You get a pretty neat result actually. You get sin theta is v by u. Pretty easy to remember. Case 2 का result is u by v, case 4 का result is v by u. So if you go with this angle, you'll get a minimum drift. And how much is the minimum drift? So BC minimum, you substitute here. This will be how much? Sin theta is v, and this is u. This is root over v square minus u square. So ud by v sec theta will be u by root over v square minus u square minus d tan theta is v by root over v square minus u square. This is u square by v minus v. And that will be u square minus v square. This will be d into u square minus v square by v into root over u square minus v square. D into root over u square minus v square by v. This is your minimum drift, everyone. If your speed is less than the river, you can't reach the opposite point, but you can get as close as to be with this one. Little lengthy, pure maths, that's just differentiation and differentiation. There's a little easier way to do, but we have to think a bit in vectors. But have a look at this. This is the main thing. If you got this, physics is over. After this, it's all max. This is your case 4. If your speed is less than the river, what is the minimum drift? Have a look at this picture. All clear with this? Take a break. Come back by 9:41. Any doubt so far? Okay, come back in 5 minutes. Yeah, let's start off. Cams on, everyone. Cams on, cams on. Why most of you are looking so exhausted, right? I think, before the class starts, please take a 10-minute power nap and then come to the class. मुझे लग रहा है क्या है ना, you guys are eating full food. Either you're having your dinner heavily, or you must be, doing all other, physical activities, running, jumping, playing in the house, and then coming to the class directly. Somewhere you're exhausted. So half of you are like, ready to leave. Like, when will sir end the class? We'll run away. So do take a 15 minutes ka power nap before the class. It helps. Then you can sit for the class. And ऐसा भी नहीं ना, how your faces look. Your faces look as if, if I stop the class right now, you'll sleep. You won't do that anyway. 10:30 when the class gets over, by the time you sleep, you go to the bed, take your phone, you roll around. By the time you sleep, it's anyway 12 o'clock. Isn't it? Or is anyone there who sleeps exactly by 10:45 or 11 o'clock here? But the way you guys behave in the class, like, so if you leave, if I just leave right now, you'll sleep. Right? So take a power nap at 8 o'clock for 10-15 minutes and then come to the class. Now, listen to this thing, right? We can also use this with the vector method. We will see one question since people wanted to use the vector method. Now, this is but it's a good one. It is an intuitive one. Think of like this, especially this question, I like to use it. Normal ones, I don't feel it. Now here, see what is happening. The velocity of the man is less than the river and you want to get a minimum drift. So what is the meaning of this? So this person here who is standing, now see, you can swim in any direction you want, isn't it? You can swim straight, you can swim like this, you can swim like this, you can swim any way you want. So if you join all these vectors, you will observe they all will form on a circle of radius v. Does that make sense? Forget about the river. If the man wants to swim, he can swim in any direction with speed v, right? Man can swim in any direction with speed v. So all these vectors will lie on a circle of radius v. All these vector heads lie on a circle of radius v. That means whenever the man is swimming, what do you need to do? You need to choose any one vector on the circle, isn't it? So depending on which vector you choose, you can get different velocities. Great. So that means all these points are going on a circle. So if you choose any one vector here, let's say if you choose this vector, so this is the velocity of the man in water. And how is the river flowing? The river is flowing like this. This is the velocity of the river in the ground frame. And we know from triangle of vectors, if two vectors are joined head to tail, the resultant vector will be from the remaining tail to the remaining head. So from this tail to this head, that will be the resultant vector, which is nothing but the velocity of the man, right, with respect to the ground frame. Look at that thing. It's a triangle of vectors. So velocity of the man in the ground frame is nothing but velocity of the river with respect to the ground plus velocity of the man with respect to the water. You can just rearrange the terms, you will see. The velocity of the man with respect to water is nothing but velocity of the man with respect to ground minus velocity of river with respect to the ground. That you just subtracted it. If you just shift it, you'll get it like this. Are you getting the meaning of that arrows there? Again, see, I'll show you what it means. Listen carefully. The river is pushing you horizontally. Agreed? The river is pushing you like this. And you decided to swim like this. So which direction will you go? If the river pushes you like this, and if you go like this, where did you reach? You reached here, isn't it? Isn't that the meaning of triangle law? The river is pushing you along the green line and you're pushing along the red line. So you reached from here to here. So this black line will be the actual velocity of the man as seen from the ground frame. This would be the actual direction of the man. Or you can see the actual path of the man. Is this making sense, everyone? There, that is the main idea there. So now we get it. Now remember, what did I say? You can go anywhere on this circle. So there are infinite ways you can actually start swimming. This is your river ka velocity. Let's say you decide to choose this vector. You can choose any vector. Let's say if I decide to choose this vector, this is 0.1. So what will be the resultant vector? So from the tail to the head means if you choose this vector 1, the man will go along this direction. That means he will go straight. He will reach this point on the river 1. Suppose if this man decides to take this point here, right? If the man decides to take this point here, man decides to take this point here, man decides to take this point here. You can choose different points. So if the man decides to take this point 2, point 3, so if he takes point 2, then you just draw the line from here to 2. Means if you take the river at point 2, you'll reach here. If you take this 0.3, you'll notice something, see. If you take 0.3, when it just grazes, you will reach 0.3. If you choose any other point, let's say if I choose this 0.4, again you'll go like this. This is a little more intuitive. You really need to understand what is happening. Are you getting what is happening? So depending on which point you take on a circle, you're going different paths. So let me draw the picture again. There are too many lines now. So this is the circle. This is your starting point. So this is how I will go. If you take this point 1, means you'll reach somewhere here 1. This is how you will go if you take this point 2. Now, can you tell me what will be the minimum drift then? You will have the minimum drift when this line becomes a tangent. Do you agree with this? If I take this point here, where will I go? Can you see again I'm started coming back? So that means the minimum drift will occur when this velocity vector becomes tangential to the circle. Is that making sense, everyone? That is the reason I'm teaching you two methods. So in case this thing looks confusing, just stick to the differentiation one. So if you take vector, this vector, and if you choose this vector such that if the resultant becomes a tangent to the curve, so if you choose this vector, this will give you the minimum drift. Because every other point on the circle will give a more drift. When resultant becomes tangent to the circle. We get minimum drift. So you're done. So this is the velocity of the man. This is the velocity of the river. If we take this angle as theta, there you're done. If you take this angle as theta, the horizontal, so sine theta will be velocity of the man by velocity of the river, which is nothing but v by u. There. So without any differentiation or anything, you'll get the same answer. But you need to understand what you're doing. Again, let me explain the whole thing. Listen carefully. See, the whole thing starts on triangle of vectors. If you have two vectors, so if the river is pushing you horizontally, you will go this way. If you try to swim like this, you will eventually reach this point here. That means it feels as if you have gone from here to here. I hope that point was understood by everyone. Now, the problem with the man is you can go however you want. That means if the river is pushing this way, you can go like this, 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 you can go like this. You can go any one of this red line you can take. So all these red lines will form a circle basically. So you can choose any one of them. So the question is this, which line should I take? Which arrow should I take so that I get minimum drift? So if I choose this arrow, this is my drift. If I choose this arrow, this is my drift. If I choose this arrow, this is a drift. If I choose this arrow, again, drift comes down. So you'll clearly notice the drift will be minimum when this arrow here becomes a tangent. That means this angle is 90 degrees. This is theta, this is v, and this is u, sine theta v by u. Is that making sense, everyone? Right, Arya, why yeah. But that's what we proved here. Is this making sense, everyone? This is an alternate method of proving it, but your maximum minimum is always there. So I'll just keep it. It's a neat one. It took a lot of time to explain, but once you understood, it will take maybe 10-20 seconds to solve. So basically, you're adding two vectors. One vector is constant and one vector is rotating, any direction it can be. So the question is, which vector should I take to get a minimum drift? So there are infinite arrows there, but this arrow will give you the minimum drift. Is this understood, everyone? Think about that, right? If you're still confused, let me know. I'll explain you under the class or maybe in the next class, but think about that. But we always have a safe method. Maximum minimum is always there. So there, this is the case 4, minimum drift. Let's see a few questions.
So in the end, we'll have to do the same thing, right? Substitute.
Which one? BC minimum के लिए?
No, after we have found sine theta is equals to v by u from that triangle method,
Yeah, उसमें तो
then we'll
इसमें
have
डालना
to
ही
do the
पड़ेगा ना?
same thing. Yeah.
Yeah. So basically, you can just avoid differentiation for that part. Let's see a few questions. Yeah, let's get this. The river is flowing with a speed of 1 kilometers per hour. A swimmer wants to go to point C from starting from A. He swims with a speed of 5 kilometers per hour at an angle theta. AB is equal to BC is equal to 400. What is theta? This is not any of the cases. This is not case 1, 2, 3, 4, nothing. So be careful. Just don't remember the cases blindly. Understand how do you solve. This man is swimming at an angle theta and he wanted to reach C. His speed is 5 and the river speed is 1. So how should he swim? Can you guess this without solving? Can you guess this without solving? Near ho gaya. It's not 45. Gods, you will get -1. Yeah, but how do you guess without solving? Listen, tell me one thing. This is A, this is B, this is C. Okay? It is given this is 400, this is 400. So this angle is 45. So my question is simple. If I actually try to swim this way, do you think I will reach C? The river is pushing you, right? The river is still pushing you. Now you tell me, if I try to go towards C, do you think I'll reach C? Because the river is pushing me, I'll go somewhere here, isn't it? Is that making sense? That means if I want to go to C, I should try to go somewhere here. Then when the river pushes me, I will go to C. Does that make sense? And this angle is already 45. That means whatever is the answer must be greater than 45, isn't it? And there's only one option. Are you getting my logic? If you try to go from A to C directly, the river will push you off. That means I need to go with an angle greater than 45. And there is only one answer, 53. Yeah, that's how you guess without solving. Now try to solve. If there are two options, 53 and 60, then you're gone. Like I said, you are lucky in this case. So that's what I'm saying. That is how you guess. Yeah. Try. I'll give you a minute. It's an easy one. I already showed you what to do. Always put a small picture. So this is A, this is B, this is C. This is 400 meters and this is 400 meters. So this man is trying to swim like this. He's trying to go somewhere here. This angle is theta. So if you look at the manka and the river is trying to push you this way with you. To resolve the components of the man, the vertical component is V sine theta. The horizontal component is V cos theta. And the river is also pushing you plus u. So this resultant must be along A to C. This is 45 degrees. This is the resultant. Therefore, tan 45 is equal to V sine theta. V cos theta plus u. This is 1. V is 5. 5 sine theta is equal to 5 cos theta and u is 1. There, I think you can clearly see theta 53 is the only thing that satisfies here. Sine theta minus cos theta is equal to 1 by 5. There. You can use a trigonometry to solve, but simplest thing, put the angles and finish it off. Is this clear, everyone?
Sir, here, due to the language of the question, could we also, like, couldn't we assume that he's swimming with a speed of 5 kilometers per hour with respect to the river?
With respect to the river, meaning when the river is not flowing. With respect to the still water, that's what he means. Parameters like this thing, see. If I say with respect to escalator, let's say you have an escalator there, and let's say with respect to escalator, you can go with 2 kilometers per hour. The meaning of that is, if you are on the escalator and if I'm standing there, I will think you're going with 2. But if the escalator itself is going with 3, that speed will add up to your 2, isn't it? That is the meaning of it, with respect to the escalator. All clear with this? Let's see one more. Relative motion is one of the important chapters, right, in kinematics, after projectile though. Let's get this. A swimmer crosses a flowing stream of width W to and fro in time t1. The time taken to cover the same distance up and down the stream is t2. T3 is the time the swimmer would take to swim 2W in still water. Then the relation between them. Let's get this.
So here is T3 the time taken to go to and fro, or just like going?
It doesn't matter, right? Still water mein, whether you go to and fro or you just go it is the same thing.
No, like, is it like both or just one way?
Nee, read now. What did he say? Read. T3 is
T3.
the time taken would take to swim a distance of 2W. Bas ho gaya. When did he say to and fro? He didn't say, so don't assume things.
Okay.
If it is to and fro, he clearly wrote it here, na? To and fro in time t1. Hmm. Any answers? A. Okay. Arya says A. Anyone else? Try. Got a minute more. This is again case 1 and case 2. This also got A. So we got a river W. So you want to cross the river up and down. So this though we already saw. You actually go at an angle V at an angle theta, that story. So this time will be W by root over V square minus U square into 2 because there are to and fro. This is T1. If you go with the river, you'll go with V plus U. If you go opposite to the river, you'll go V minus U. So this time T2 will be W by V plus U plus W by V minus U. This will be 2VW by V square minus U square. Here in still water, you're just going with V and this is TW. So T3 will be simply 2W by V. There, so you need to think, if I square something, what will I get? You actually, if you see the denominators, right, this is V square minus U square. This is root over V square minus U square. So if I can square T1 square, I will get T2 ka denominator. That should give you a hint. So let's do T1 square. That will be 4 omega square by V square minus U square. This can be split into, if you multiply T2 and T3, you actually get this first option. Yeah, right, Utsa. Right, Samyak. Easy, got this? So there, you combine case 1 and case 2. Any doubts on this? Clear, na? Yeah? You got it anyway. Ishman? Aditi? Got this? Advait? Shreyan? Srihari? Perfect. Next one. This is a good one, right? Aeroplane and wind. Same story, just like a river pushes a boat, a wind also pushes an aeroplane. Did you guys ever hear this word, slipstreams? Did you ever hear this term called slipstreams? So what are slipstreams? Think about it. Just like you have a river on a land, river is nothing but flow of water. In atmosphere, right, there is something called slipstreams. So these are some, wind patterns where the wind is blowing continuously in a particular direction. So these are called slipstreams. These are like rivers of, air which is flowing in the atmosphere. So if you can take your plane and put it on a slipstream, you'll actually get the extra speed of that slipstream. Let's say the plane is flying with 700 kilometers per hour and the slipstream is going with 60 kilometers per hour. So if you take your plane and fly in the direction of the slipstream, your speed becomes 760. So there are certain companies, right? What they do, they're actually tracking the slipstreams day in, day out. Every day they keep tracking them because these things keep changing a bit, and they sell this data to these, airlines. And these airlines, what they do, let's say if you want to go from city A to city B, and let's say they found out there's a slipstream like this. So instead of just going straight, what they will do, they'll try to go to the slipstream, they will try to follow this, and then they'll get out of it. So even though the distance is a little more, you get this additional velocity. So you can benefit with time and you can save some fuel. It becomes cheaper. Same things happen, in the oceans also. You have underwater currents. So these are the rivers which are flowing in the ocean. You saw this thing, Finding Nemo, in that the fish actually gets lost like that. There is a underwater current. The fish tries to go there and it gets dragged away. So on land, we call it a river. In the ocean, we call it underwater currents. In the atmosphere, we call it slipstreams. There is a similar concept in space also. We'll talk about that in electrostatics, but there is something called, equipotential surfaces. So in space, right, there are some region called equipotential surfaces. When you travel on that surface, you don't need to spend any energy. You will go automatically. Did you ever think about it? This NASA and all this, big space institutions, right? They use what do you call it? Supercomputers for navigation. What do you think they're trying to do? They're actually trying to figure out the paths and they're trying to calculate, these equipotential surfaces. So let's say you want to launch something from A to B, right? And you found an equipotential surfaces like this. So instead of directly going to B, what they will try to do? They will try to reach the equipotential surface. Then let your satellite travel along this because you need not use a single amount of fuel, a little bit of fuel also. You can just follow this equipotential surface. When you get closest to B, then you get back to B. This way you can conserve a lot of fuel. So, but it is very difficult to calculate these things because this thing gets affected due to the motion of all these planets and stars. So requires a lot of calculations. Sometimes the simulations will take months just to get one trajectory. So if you have a faster computers, you can actually plot this and you can send it. Just to give an idea, ever heard this word slingshot? Gravitational slingshot. So let's say you want to launch a rocket to Pluto. You know how they launch it? Let's say Earth is here. This they actually did it, with the I forgot the name. They launched a satellite in 1980s towards Pluto. It took almost 20 years to reach.
New Horizons.
New Horizons? Okay, that is the name, I guess. So when they try to launch something really far, this is what they do. See. So let's say this is Earth. I'm just giving a rough approximation. Let's say this is Venus. Pluto is somewhere here. These people, they launch the rocket towards Venus, opposite direction. So as this is going here, the Venus approached here. So this rocket, satellite got stuck in the gravity of Venus. Now what the Venus does, it takes the satellite, rotates around it, and then it throws off, just like a slingshot. So, so every time you do a slingshot with a planet, you gain more velocity. As this is going here, and these people have calculated the trajectory so nice, the Mars is coming here. So this thing goes here somewhere, the Mars is here. Mars catches this planet, does a slingshot. Then Jupiter is here, it catches the thing, slingshot. Saturn is here, slingshot. So they're using this planet's gravity, in order to throw this thing faster and faster and faster. And by doing that, even though the path looks bigger, they actually saved 2 years of time. Instead of launching it directly by using this method, right, they decrease the time interval by 2 years. So there's a lot of stuff. We will learn this in gravitation, how to do a slingshot. But anyways, now let's get back to this question. So if you have a plane and if the pilot ignores the wind and just tries to fly the plane straight, the wind is going to drag you out. That's what happened in this question. Try to draw a picture. We have two cities A and B, which is 1,000 kilometers due north. The pilot neglects the effect of the wind and goes, and he found he's 300 kilometers north of east. Draw the picture, you'll understand. If you can draw the picture, you'll know how to do. I'll give you a minute. Did you get the picture? This is city A. This is city B. This is 1,000 kilometers due north. This guy neglected the wind and he went away and he reached 300 kilometers due northeast, meaning northeast, that is 45 degrees. This is 300 kilometers. You reach C. So this plane, which is trying to go straight, actually went to C. This is what happened to the plane. I hope the diagram is clear. Now solve the problem. Now he's asking what is the velocity of the wind. So actually what happened? The plane was trying to fly like this. So the pilot was trying to go like this. He's trying to go straight. But the wind dragged you to point C. That is what happened. The plane is looking straight, but it is going at an angle. So how do you start? We have B answer, we have A answer. Let's see. Yeah, Aditi, you reach your destination before time is because the Indigo and this Air India, what they do, it takes 1 hour for the journey. They'll tell you it is 1.5 hours. They always reach on time. Because if you go late, they are fined. So instead of telling you the exact time, always put an half an hour buffer time and reach early and say, there, we reached early. See. They do that. I noticed this thing. I used to fly in 2015 and all. From Mumbai to my hometown, it used to take 1 hour 10 minutes. Now they show 1 hour 30 minutes. The planes have become slower in the last 10 years. The planes actually reach in the same 10 minutes, 1 hour 10 minutes. And the pilot says, there, see, we brought you early.
That's a
We also
very
feel happy, na?
big,
Ah.
yeah, that's a very nice marketing. Because then your customers will think, wow, such good airline we reached earlier.
But then when you go to the luggage counter, you have to wait for the luggage for half an hour anyways.
That's
So,
traumatizing, sir. We don't talk about that.
so what is happening here? A, most of you are getting it. Okay, listen, see. The problem, we don't know how the wind is blowing. So this is one scenario. Whenever you don't know the wind is blowing, you take two directions. So this is A, this is B, this is C. This is your 1,000 kilometers. This is your 300 kilometers, and this angle is 45 degrees. Since we don't know how the wind is blowing, let the wind curve be Vx and Vy. So always take two components. Let velocity of the wind be. So keep that thing in mind. If you don't know how it is flowing, you can always take two perpendicular components. So if you can find Vx and Vy, my job's done. Let the velocity of the wind be Vx I cap and Vy j cap. Perfect. If you look at this distance here, this will be 300 cos 45, 300 by root 2. This will be 300 by root 2. Now look at your plane. Your plane is flying straight with 500 kilometers per hour. On top of it, now your wind is getting added to this. So that will be plus Vy. And the wind is also pushing you horizontally with Vx. So this plane is actually flying straight with 500 plus Vy and horizontally with V100 plus x. This is the plane ka speed. So this will be the velocity of the plane with the wind. There. So in the vertical direction, how much did you actually travel? In the vertical direction, you travel 1,000 kilometers and also you travel 300 by root 2 kilometers. So you travel 1,000 kilometers straight and then you travel 300 by root 2 straight. This will be nothing but 500 plus Vy into time. And it is given the time is 2 hours. This is the vertical direction. So if you just simplify this, how much will this be? 1,000 will cancel. You will get Vy is equal to 150 by root 2 kilometers per hour. In the horizontal direction, the plane has traveled how much? 300 by root 2. That came because of the wind only. This is equal to the horizontal wind into the time is 2 hours. So Vx is also 150 by root 2 kilometers per hour. There, you are done. So Vx and Vy is 150 by root 2, 150 by root 2. The speed will be 150 kilometers per hour, and the direction will be I cap, J cap, northeast. So first option. Is this making sense, everyone? So the plane is flying straight with 500. Your wind is pushing straight with Vy and horizontally with Vx. So net you traveled 1000 and 300 by root t in the vertical direction, and horizontal you traveled 300 by root 2. Is this making sense? So this is what a wind does. It pushes the plane. It gives an additional speed in the direction of the wind. Any doubts on this? Any confusion? Srihari, Tanishka, Yashvi, Utsa, Advait? Great. So there's one more problem in the riverboat problem, but I want you to try this. I'll give you this as a homework. So try this and come. Next class we will discuss this because I want to give time to this. I want you to think. This will be a proper advanced level problem. So definitely try this. Don't come without trying. Yeah, but at least give it a try. It's okay if you don't get an answer, but I wanted to spend some time on it. So we got a river here. Now, if you actually think about a river, rivers don't flow with constant speed. So let's say this is y0, this is y is equal to d, and the center of the river is y is equal to d by 2, the midpoint. So we have point A here, we have point B here, exactly opposite point. So this person here, velocity of the man in still water is v. Now this velocity of the river rate is not uniform. Think of how the river flows. When you're near the bank, the river is going very slow. At the center of the river, it goes fastest. So velocity of the river increases. At the banks is 0, river bank, and increases linearly till the center. Meaning, if you actually try to see the velocity profile, it looks like this. So at the corners, the velocity is 0, the river is not flowing. Here, the velocity is 0. Then the velocity will increase, then the speed will increase, increase. Then again decrease. I need more arrows. Increase. Something like this. Can you see how it looks? So at the center of the river, the velocity, the river is flowing the fastest. This occurs at exactly middle of the river. Generally, this is true. At the center of the river, it is flowing the fastest, and the edges, it is going the slowest. Let's take it u. So speed of the river at the center is u, which is maximum. This is the maximum speed. Is this clear, everyone? The story is clear so far. So we got a river where the speed of the river at every point is different. Now, what this person does, he just ignores the river and he just swims straight. Just like that aeroplane in the previous problem, he just ignored the river and he goes, straight swim straight along AB, straight ahead. Meaning he's always looking front. But then I know because of the river, what will happen? It will drag him out. Man ignores the river and swims straight with speed V. So the first question, find the time taken to cross the river. Second question, find the velocity of the river as function of y coordinate. Y is the width of the river there. So at the corner it is 0, at the center it is u, and it is said it increases linearly, meaning the function will look like y is equal to mx plus c. Find the equation of trajectory, meaning when the man is going, what is the equation of his path? He will not go in a straight line. Question D, find the drift. So once he reaches the other side of the river, where will he reach? He will not reach B, he will reach somewhere else. What is the drift? X cube is 0. Where did you get that function from? Right? Is the question clear, everyone? So try this and come. So next class, first thing in the class, we'll be discussing this. But spend some time, right? It is a QWERTY question. You can spend some 20 minutes to half an hour. It is fine. But again, when you spend 20 minutes to half an hour, don't spend at a stretch. Like sit with the question, try for 10, 12 minutes. Not getting it, leave it. Next day, try again for 10, 12 minutes. Next day, again, try for 10, 12 minutes. And yeah, and Tuesday, we will discuss this. You got something, great. You don't get anything, that is also okay. But trying is important. Only when you try the questions, right, your brain will understand how to handle something new. This is what will happen in the advance. They'll give you something completely little weird out of the box and they'll expect you to solve. So if you don't train your brain from now, right now it might take half an hour. But if you teach your brain how to think, by second year in 12th standard, it might become 5 to 6 minutes. Yeah, that much time you have to solve a question. But any doubts on the question and the data, please ask. Question is clear. So try this, right? So next class, when we catch up, we'll continue from here. We will, there is 1 or 2 more problems on this relative motion. We'll do that. And then we'll go ahead with graphs. So graphs is the last part in kinematics. So we have done almost 69 questions. So do finish it off. I'll send you a sheet also on kinematics today on relative motion, projectile, all combined. I'll send you 1 or 2 sheets. You can start doing that. Okay, with that, we'll wrap up for the day. And there's a test deadline today. I hope everyone has given it. But in case someone is not given, there is a, you can still write the test till 11:30. So give it in case you